So hello guys and welcome to another video of Only Sai No Pi. Don't forget to like, comment, share and subscribe. In today's video I'll be talking about ELISPOT, which is basically another video in the lecture series of immunological techniques. So without any delay, let's get started. ELISPOT is basically uh, an assay which has a variation of ELISA, or you can say a modification of ELISA, wherein ELISA measures the antigen antibody complexes, that is amount of antigens or antibody in the sample. Now, since I've already discussed much about ELISA in my previous video, I won't be getting into those details. However, if you haven't watched that video yet, I'll be adding that link in the description below. So, while I was talking about ELISA, ELISA measures antigens or antibodies in the particular sample. ELISPOT measures the frequency of cells secreting the certain cytokines, or not only cytokines but also some signaling proteins or antibodies secreted by the cells. Next is there is a variation of ELISA which uses fluorescent compounds rather than enzyme substrate complexes to observe the particular reaction. So let's move on to the protocol, wherein ELISPOT, similar to ELISA, what is done here is either a monoclonal or polyclonal antibody is coated onto the microtiter plate, following which our sample containing cells which are secreting cytokines are added to this well plate. What happens here is when the cells are added, these cells secrete cytokines in the plate. These cytokines are attached to the antibody which is attached to the microtiter plate, and yeah, so as I mentioned, the immobilized antibody in the immediate vicinity of the secreting cells binds secreted analyte. Our analyte is cytokines. Now what happens at the next step is we wash away any cells or any unbound cells. Secondary antibodies attached to the biotin compounds are added to these wells. This biotin is basically used wherein for the enzyme to attach to the secondary antibodies. Next, our enzyme is added, and then following this substrate is added. So what happens is wherever there were cells initially in the microtiter wells, cytokines were secreted which were attached to these antibodies, and then secondary antibodies were used to check these um, cytokines. The presence of spots in the medium indicates that our particular cytokine producing cells were present, and therefore the enzyme converted the substrate into a colorful product which can be observed on this plate. Now, observation can be done using a stereo microscope, as I said, or a plate reader, wherein presence of these spots indicate our cytokine producing cells were present or proteins producing secreting cells were present, and also we can say that the number of spots are proportional to the number of cells. So if my cell was here, they have produced cytokines, and the substrate is converted into product, that is colorful product, and we observe a spots. So the bottom line is the number of spots correspond to the number of cells in the sample. Applications of ELISPOT assay includes that we can use this assay to detect the presence of certain infections. That is, in response to certain infections, certain cytokines are produced, and these cytokines are present in the sample. So if no infection, no cytokines, that is control, whereas infected individuals can show, or infected samples show the presence of spots. Another application is that we can also use to compare the cytokine titer and estimate the immune response of that particular individual, wherein individual 1 shows more number of cytokine producing cells, indicating a higher immune response or a later stage of immune response different from individual 2. So just to summarize everything what we have seen, that ELISPOT is extremely sensitive technique wherein individual number of cells on a small scale can also be estimated. It allows quantitative measurement where a number of cells, as I already mentioned, can be estimated, and it can be used in diagnosis of any disease. That is, even autoimmunity can be detected. It can be used in vaccine development to quantify, compare immune responses, etc. So I hope you like this video, and if you do not forget to like, share, comment, and subscribe.